as you work on your pre-lab, you're going to write down procedural notes, and you need to make your own data table. It's really important as a chemist to be able to read over procedures and identify the data that you're going to be recording in lab. I highlighted all of the data that we're going to be recording. The key terms here: record the mass in your notebook. Okay, so that means you have to record something. So it says wearing your protective eyewear, tare your beaker, so it'll be zeroed out. Add a scoop of copper 2 sulfate pentahydrate in the sand mixture. Record the mass. So that first mass is going to be the mass of your initial mixture, which is what we're looking at here. Then we're going to add deionized water. Remember, that means your copper 2 sulfate, which is water soluble, it's a salt, will dissolve. And you're going to swirl to let it all dissolve. Weigh and record the mass of a clean filter paper. So that's our second data point here. Note, you need to, when you're watching the video, think about what is being weighed out, because the items are not weighed out in this order. So you need to think about what you're watching. You're going to then put together your filter apparatus, you'll see that, and then record the mass of a clean, dry evaporating dish. So that's your next data point. Place it beneath the funnel. So this is going over your setup, and you're going to see, so carefully make these notes in your procedures. You'll watch the video. We're going to take the filter paper out after filtering, so what'll be left in the filter paper is sand. You're going to open it up and dry it out in an oven, and then you're going to record the mass of the filter paper and the sample once it's dry. So remember, the sample in the filter paper is indeed the sand. This is now the setup for our evaporation step. We're going to have the filtrate. Which is our aqueous copper 2 sulfate pentahydrate. So the copper 2 sulfate and the water, hot water bath, and a Bunsen burner. The Bunsen burner obviously gets hot. The water gets hot, it boils, creates steam and a lot of heat. And what happens is the water evaporates and the copper 2 sulfate is left over. So you know you're finished with this step because you're going to have no more water. The evaporating dish will be dry, and there will be a thin layer of your light blue copper 2 sulfate pentahydrate left over. And then once it cools, you're going to determine the mass. So that's the mass of the evaporating dish and the sample, which is our copper 2 sulfate pentahydrate. I am now going to go over just kind of an overview of the calculations you'll be working on. What I've done, I wrote down sample data, so just data that I'm going to use. You need to use your data based on the number that you were given. Let's look at number 1A. 1A, calculate the mass of the copper 2 sulfate pentahydrate recovered. So let's think about this for a second. How do we get our copper 2 sulfate pentahydrate back? Well, remember, it was aqueous in your evaporating dish. So we know this is our evap dish. And we'll call this, let's see, clean evaporating dish. I'm going to call this, these are going to be, let's do this. I'm going to number these. 1, 2, 3, 4, 5. Okay, this does not correspond to data points A, B, C, D, E. You need to figure out which one is which based on the video. So our evap dish, I know, is 0.3. So that is 63.883 grams. And then what happens, you're left with some of that dry copper 2 sulfate pentahydrate left over. And then we have the mass of both the evap dish and the leftover blue solid, which is our copper 2 sulfate pentahydrate, which has a mass of 65.178 grams. So if I want the mass of just the copper 2 sulfate pentahydrate, just that solid, what do we need to do? Well, if 65.178 grams is the mass of the evap dish and the solid, 63.883 grams is the mass of just the evap dish, we can then subtract them to get the mass of just the copper 2 sulfate pentahydrate left over. One B, we want the mass of the sand recovered. Very similar thing. So we have our filter paper, clean filter paper. With a mass, let's look, this is 0.2 in my notes. You have to figure out which letter that corresponds to for your data. and a mass of 0.939 grams. So you can see it's much lighter than the evaporating dish, which isn't surprising because this is paper. And then what happens? We have the sand added to it. I'm going to have some green sand. So our green sand, it's not actually green, just in this drawing it is. So our filter paper plus the sand is 0.4, 8.922 grams. So if we want the mass of just the sand, what do we need to do? Well, if this is the mass of the filter paper plus the sand, how do we get the mass of just the sand? Well, we need to subtract the mass of the filter paper. And we end up with the mass of the sand. Make sure you use your sig fig rules. So our masses from the digital scale all have 3 digits past the decimal point. Keep that straight, and you need to have units of grams. And as usual, box all of your final answers. I'm going to call the answer. So in 1A, we get, I'm going to call this X grams of our copper 2 sulfate pentahydrate. In 1B, I'm going to call this Y grams of sand. You need to use your actual numbers. Here I'm just using letters. So you can then use this setup and apply it to your own. Number